Today we're going to be talking about location security within the WyzeCam device. WyzeCam device is a video streaming service or device that allows you to live stream video as well as record different events. And it can specifically meant for home security or any sort of video monitoring that's required. This device comes in at the cheapest one they offer is about $20, and they have what's pictured here is the WyzeCam pan, which can actually rotate in circles. So the company boasts that they're able to secure traffic with AES 128-bit encryption, and they use TLS 1.2, and they basically state that they're following security best practices around the world. So the main goal of this research paper was to verify whether, in fact, this was all true. So the overall system is pretty straightforward. And this image details out kind of the basic network configuration. So we'll start on the left side. So on the left side, we have the green box, and this represents your internal, usually a home network, where we have the WyzeCam device, a router that has an external port facing the internet, as well as we may have a mobile device that's running the WyzeCam mobile application. Next, if we move to the next cloud in the middle, we have the ThruTech third party that is used for mainly the UDP streaming of video. And then on the far right next we have the AWS WyzeCam servers, which are used for the APIs as well as authentication and finally the storage on AWS, where you can actually store 14 days of video for free within the WyzeCam services. So moving on, we'll start at the WyzeCam device. So you'll see that there are three different color of arrows. So arrows represent the internal communication within your network. So that will include UDP, TCP, and HTTP traffic because it's coming directly from your WyzeCam device or mobile device that needs to talk to both through the ThruTech system as well as straight to the AWS servers hosting the WyzeCam APIs and business logic. So next we see the purple line. So this represents the UDP traffic, and this is mainly used for the video streaming. And you'll see that these arrows are bidirectional. So this is the way that we're actually able to communicate from outside the world back to your WyzeCam device. This is all via this ThruTech system that uses a capability called UDP hole punching. So the way this works is whenever this is set up, you put in your username and password, and then on your router, what happens is we state that for this sort of traffic, we need to have a route back to some device inside of our network. So this allows the WyzeCam servers to be able to talk through the ThruTech systems back to your WyzeCam device for certain capabilities. And then finally, we have the yellow arrows. So the yellow arrows represent TLS, TCP, and HTTP traffic. And this is only one way from the WyzeCam device or mobile device. So next, we'll be talking about the outbound communication. So typically, we want to limit any sort of outbound connectivity to specific servers. And if we're seeing traffic going externally to IPs and endpoints from a device unexpectedly, that raises some concern. So what has actually happened was a year ago, somebody reached out to the WyzeCam support via Twitter, realized that there are UDP traffic going around the world. And this was actually to the ThruTech system, who had their servers load balanced around the world. But most users in the US specifically did not want their traffic going through servers hosted in places like China, Germany, and anywhere outside the US. It's due to the possibility of the differences in um, restrictions, security and privacy. So um, what WyzeCam had to do was work specifically with ThroughTech, and now pretty much all this outbound communication should be to IPs that exist within the US. And as you can see from this list, we see traffic going to UDP or UDP, TCP, NTP, which is for the uh, time tracking, DHCP, HTTP, and all these are going to mainly AWS servers. But the rest of the servers that are listed here are also all located in the US. And this all came about from one user noticing the traffic and asking support, which then uh, um, pretty much the WyzeCam engineers to figure out what was going on here and ultimately fix this concern right here. So next we have a little bit of background information on the inner workings from the WyzeCam device that we were able to uncover. So using Nmap, we were able to find the MAC address, the OS version, which is Linux 2.6, and the server that is running is a BOA server. And then we were also able to track down the open ports, which included port 80 for TCP and HTTP, and port 10002, which is used for TCP and UDP traffic. So next, I just want to talk a little bit about the internals that I was able to uncover about the WyzeCam device. So using Nmap, we were able to track down the MAC address, the Linux version, which was Linux 2.6, and also even the server version, which is a BOA server, and this is open source. The open ports that we're able to see are port 80 for TCP and HTTP, and then we can also see that port 10002, which is used for TCP and UDP. And this is specifically used for communication from that TrueTech system to talk back to the device. So there are a couple things that we were able to see when taking a look at and decompiling the mobile application. We can see that there's a number of third-party services being used. The uh, Zion uh, camera, which is used internally, I was able to track down in one of the firmware updates, you can see that there's a plain text RSA key, but based on what I was able to see, the MAC address associated with that should be specific to one device. So that seems to be a default username and password that's used in the device, but I couldn't find much more detail on it. And the last things were the TCP sequence prediction. It seemed like it was very difficult to predict, and then the IP ID sequence generation that was set to all zero. So next, moving on to more of the automated analysis. So in order to run some automated analysis, what I did was I took a look at a network trace of the TLS communication from the WyzeCam device talking to api.wyzecam.com. So in doing so, what we were able to see is this is following the basic TLS 1.2 protocol. So we have the WyzeCam that sends the server hello, client hello to the server. The server responds with server hello, the server certificate, the server key exchange, and then the WyzeCam sends its key, a change cipher spec, and encrypted handshake to the server, and then the server responds with the change cipher spec, encrypted handshake message, and then the communication all begin. set for the RFC pretty closely, as we can see here. We have client hello for client, and then server hello, and same steps that I had mentioned previously. So the next step to take was to take that specific TLS model, try and model it in Proveris. Proveris is a monitoring and verification tool that allows you to set up a specific algorithm and then run some automated analysis to see if an attacker can intercept specific secrets and keys throughout the communication process. So the tool itself has quite a bit of a learning curve. Um, the documentation is pretty good, but it's not it's kind of a straightforward tool to kind of pick up and run with in a very short amount of period of time. The other tools I looked into were Casper, and most of the other tools that I was able to find didn't really have a good uh, development and experience within Windows, so that was why I stuck mainly with Proveris. So based on the results I got from my uh, algorithm, algorithm that I had set up in Proveris, um, reported back that in all the different scenarios that I ran the tool against, that the return indicated that the attacker was not able to intercept any sort of information, for example, the pre-master secret, the master secret, or any thing in between the server authentication. So the way I began with this setup was first by finding a baseline example running 1.2, and then from that example I was able to modify it. This is exact scenario. Um, didn't include things like client authentication um, uh, and the client key exchange in the order that this original example provided. So if we go into Proveris, so here is my sample that I had set up. And first it was setting up some different functions, and setting up the queries that I wanted to investigate whether an attacker would be able to see the inputs or not. Next was setting up the client side a portion of the queries, and then next was the server side, and then finally the algorithms. So if I run this tool, at the very end you can see what the output from the PowerPoint indicates that the attacker was not able to enter. One other thing I didn't mention previously goes into a little more detail talking about location, the nonsense that are passed back and forth, the um, session ID, and then things like the crypto algorithms that are decided by each of the client and server. So this goes into a little bit more detail than what I'd shown previously on this slide, with when the at what point the session IDs are shared, which would be here where the server hello occurs, because the client hello is not reinitiating a TLS connection, and then also within each server and client hello will be passing on the um, each user. And one other thing we were able to verify in the communication, we do see that the server designs an algorithm that includes um, Diffie-Hellman, which provides a perfect forward secrecy, so that in case that a private key for a certificate was keynoted and collected by some service, that information would not be able to be decrypted. This provides additional security for the user's data. And the last thing I want to mention is because UDP does not have the same handshake that TCP, that with the created. From what I'm able to is that they're using encryption. So each device, as stated by WyzeCam, has its own certificate. So from what I understand, the encryption is probably being for UDP traffic is encrypting the video streaming as it goes through text systems, which should not be able to decrypt that traffic, as stated by WyzeCam that client and server side that this traffic uh, by wouldn't be a way to validate this because all this is occurring directly on the device itself. So we would not be able to um, uh, in a easy way be able to figure out how the encryption is occurring between the two entities. So this was something I spoke about before, how a Reddit user had changed how the communication going to outside IP addresses in other countries, how this was changed due to the user voice, and I mean this provides some additional user assurance that the company is doing its best to make sure that all security concerns are addressed by from their users. So next, how we can strengthen our network. So for limiting inbound connections, we can lock that down to port 80 and 10.0.0.2 because we know that traffic will only be coming in from that specific port. As to the IP, because this is a third-party system, a lot of the times with these services, they don't have a static um, IP address. So those IPs could be coming from different IPs as uh, um, the IPs may change dynamically. A VPN connection doesn't really make a difference because all communication from the WyzeCam device and mobile device all go through the centralized API service. So using a VPN connection would not make any difference. The last thing is to make sure that you keep your device firmware up to date, and this will have the latest security patches for your device. The last thing to do is keep in mind that your data is being stored in another third-party service, so there's no way to actually control how this data is stored on the AWS server or in the WyzeCam. That about covers it for a basic overview of the research that I did and the overall findings that I found was that the WyzeCam, for the most part, at least with the communication to external parties, as well as what's happening on the mobile device, all seem to be following best practices to make sure that user data is secured. The one thing to mention though is that all of your data is being processed on some external servers. What's happening on that end, but we really wouldn't have visibility into what's happening there. There's been a lot of asks to see if store data, we as WyzeCam users can store data on our own AWS S3 buckets um, for at least a better understanding of what and how this data is being stored, but um, this hasn't been addressed directly by WyzeCam. For the most part, the WyzeCam device uses 1.2 with the um, following the RFCs for TLS 1.2. We use UDP, HTTP, and TLS traffic. For firmware updates, they're all being downloaded directly from the WyzeCam API servers. There is a way to update the firmware remotely using an SD card. So if somebody is more security conscious, you can actually have your device completely offline, which would basically prevent any sort of internet access or the ability for somebody to maliciously access your device. But with doing this, you are not able to use any of the capabilities such as live streaming or even configure the WyzeCam device for events and things like that. But overall, from what I found, the device is very security conscious, and it's for an entry level device for this price. Uh, I uh, I can't see where you would go wrong with your internal network. But like I said, or you may be able to use things like locking down all the inbound traffic and to specific ports and locking down outbound traffic specifically where it's going to certain I would say certain ports. For IPs, like I said before, IPs may be dynamic, so they may change over